Welcome everyone. In this video, we are going to get introduced to a structural tool, namely three-moment equation for the analysis of indeterminate continuous beams. Let us consider a beam that has fixed support at one end, roller support at another end, and is hinged internally at the middle. Now tell me whether this beam is statically determinate or indeterminate. The beam has 3 plus 2 plus 1 equal to 6 number of reactions in total and has only 2 segments. Since the total number of reactions equals 3 times the number of segments, we can say that the beam is statically determinate, and we can find out the reactions and internal forces by solving the corresponding static equilibrium equations only. We should not apply three-moment equation for such beams. But what about this beam? This beam or this beam? Is any one of them is statically determinate? Of course not, because all of them have got some degree of indeterminacy. 1, 2 and 3. Oh sorry, it's 1. All of the 3 beams are indeterminate beams. To find reactions and internal forces in indeterminate beams, the equilibrium equations alone will not suffice. In that case, we will need some extra conditions to formulate one or more compatibility equations. The number of such equations required will be equal to the degree of indeterminacy or redundancy present in the beam. 2 types of methods are used to analyze indeterminate structures, namely displacement or stiffness methods and force or flexibility methods. Under the category of force methods, we have got the flexibility to use, method of consistent deformation, method of least work, and three-moment equation. Three-moment equation was introduced by Emile Clapeyron in 1856, and so it is also called as Clapeyron theorem. It can be conveniently used in the analysis of continuous beams. The compatibility condition used for this method is that the elastic curve will be continuous at all of the intermediate supports of the continuous beam. To understand the concept of continuity, let us consider an intermediate support A of a continuous beam. Let us draw a tangent at the point just left to A and another at just right to A. Now the elastic curve will be continuous if and only if slope of the left tangent is equal to that of the right tangent, otherwise not. The bending moments at the support under consideration and at 2 adjacent supports are used to formulate the equation. That's why it's called three-moment equation. The basic concept of the analysis with three-moment equation is that the bending moments at intermediate supports are considered redundant unknowns. The supports are combined in a sequential order to give a set of three-moment equations, and the equations are solved simultaneously to determine the unknowns. That's all for now. Thank you very much for watching this video. More derivations and problems on three-moment equations are coming next. Wait till then. Bye.